Right, hello everybody. I'm Andrew. I work at Jumping Rivers. We're the ones hosting this conference, the blue shirt people. And I want to talk about Shiny in Docker. And so it's not going to be totally a technical talk, but a little bit of code occasionally maybe. But so the purpose of the talk is really to say that it's easy to do if you know how to do it, and it's not that hard to learn how to do it. And talk about the reasons, like why you would want to bother with this, what the value of doing this is, and how to avoid some of the really easy to fall down pitfalls with trying to combine these two technologies, I guess. So, and how to know if it's good for your use case that you've got for a Shiny app. So first to say, I'm from Jumping Rivers. We do, we're a data science consultancy, but we also do data engineering. So the data scientists go and help. Well, you're all data scientists, presumably, so you know what data scientists do. I'm in the engineering team, so we go into organizations and give them the tools to do the data science they want to do. So that might be as simple as deploying an IDE for them to run R and Shiny in, or it might be deploying a whole suite of tools. Sometimes they don't know what they want, so you're going in and you're having that conversation about, again, why are you trying to do that? Could you just not? Ideally in nicer language than that, but that's kind of the aim of what we're trying to understand is what are you trying to do and why, and is what you're trying to do sensible, and if so, how can we help you with that? Sometimes it's as simple as just go and read what Git is and learn and use that, and that's all you need. And sometimes it's let's help this organization build a data strategy and start from scratch and go and build out from there. Transforming collaboration is the fancy way of saying use Git. What is Shiny? I'm not a Shiny developer. I vaguely know what it is. I know that you can have quite niche, complicated apps. I know you can have very standard-looking, normal apps. And I know you can have silly apps. And there we go. There's plenty of talks on what Shiny are here. Go and watch them if you don't already know. But if you do know what Shiny is and don't know what Docker is, then this is probably OK. If you know what Docker is but don't know what Shiny is, then tough. If you don't know what either are at all, then why are you here? OK, so what is Docker then? So it's kind of a way to put all of the stuff underneath our packages in one place. So all your system libraries, your kernel of your machine that you're running on, your virtual machine, you put all that in one place and wrap it up, and then you can deploy it. And you encapsulate those tools. So not just dependencies, but also just system tools that you might want to use. And you can put that in a box. So it's with all the version strings attached. So something like rn-vpacrat, but for system libraries and tools rather than for packages. And so the reason that this exists, rather than just having a VM that has all the stuff that you want on it, is that it's fast and it's lightweight. You can start a container in seconds rather than minutes waiting for something to boot, because there is no booting. It just pops up and runs. For some definition of pops up, it's more complicated than that. Trust me. Also it's more portable. So whereas you build a VM and you install everything you want, or you've got your laptop, you install everything you want on it, you can't then just lift and put all of the stuff you want on it somewhere else. Whereas by building a manifest and making a Docker image and putting your application in there, you can just take that Docker image and put it on anywhere that has a Linux kernel that is within the last 10 years or so, and it will, if it worked over here, it'll work over there. That's really the big bit is the portability. However, it is less standalone. So if you can't just have a container or a Docker image and just run it. You need infrastructure around that. You need a runtime that is going to do all of the stuff and take all of the kernel calls and parameter calls and interpret them and do your networking and do your storage and your disks and all that. You need to have infrastructure around a container for it to work. Otherwise, it's just nothing. It's just 30% of a computer. So that's what Docker is. So when you've got an app, when would it make sense to Dockerize this app? And the first one is if you don't have Connect. If you have Connect and you've got an app and Connect serves your needs, just use that. If you don't have, or some other platform where you can deploy Shiny code to just natively, then that might make sense. If you need to do more than Shiny Apps.io can give you, so if you need to have, if your application needs to have integrations with complex authentication mechanisms, or do more advanced integration with something like SAML than Shiny Apps can, like with Azure, it makes a bit of a mess. You can do that. If you Dockerize your app and deploy it to a platform that can handle that integration, that authentication for you. Similarly, if you want to integrate with a private data source, Shiny Apps.io is cloud and it's public. If you want to have something like a caching layer, so we've talked about, or Chris talked about, wanting to be able to cache, using caching to reduce the load on a server. If you want to have a whole caching tier of your infrastructure that does all that in front, then Shiny Apps isn't going to give you that. Or if you want more than 8 gig of RAM, also I'm not really trying to diss Shiny Apps. Like, there's a load of good use cases for this platform, but there are times when you wouldn't, and those are the times, and Dockerising sometimes can help you there. Also, if you're in an organization and you have an account for AWS or Azure that no one really cares about, and you can just use it and deploy things on there, Dockerising an app and sticking it up in something like Azure Web Apps or Elastic Container Service on AWS or Beanstalk, sort of, is a way to get going with this really quickly. Or rather, a place to put this stuff really quickly that can be really scalable and work. When not to Dockerize is if your app is really stateful. So if you're doing caching in memory in your app, and you Dockerize it, and you've now got 3 or 5 or 20 copies of this app running at the same time, and you're not being careful about how you set affinity so everybody always goes back to the same instance, then people are going to have a bad time because they're going to have made a cached copy, and the app's going to expect it to be there, and it's not, and it's going to break. So you need to be careful around stateful applications and where that state is being stored. If you can store that on shared storage, then you're going to be okay. But if not, and it's all contained in your app itself, then yeah, it causes problems. And you need to sort of pull that out first before trying to Dockerize the actual runtime. If you don't version your R packages, just do that first. Just, you can oh, Docker's going to put everything in a box and capture all the versions for me. Yes, technically it is, but you're not going to be able to introspect on what any of those versions are later. Whereas if you use something like Packrat or Renv and build a lock file, and then just when you're building your container, you just install from that lock file, it's going to be much easier to do and much easier to introspect later when you're trying to understand why something doesn't work the next time it builds. Another reason is if your app needs root access. So sometimes you have an app and it needs to do something as root on a box. I don't hate that, but if you cannot do that, don't do that. But if you have to do that, then fine, it might not be sensible to Dockerize the entire application. Maybe you Dockerize most of that functionality and call out to a different endpoint that has to do something as root on a box somewhere else. Also, if nobody knows how to use Docker at all, and you've got a bunch of stuff that you're trying to deploy, yeah, maybe not Dockerize it, because it's like there's a bunch of infrastructure you need to understand. Or if no one in your organization has heard of Docker, not your IT guys, not you, not anyone, then you might have trouble if you're a lone data scientist trying to spin this up and get this deployed. If you've got that secret little AWS account you can just use, maybe not. But yeah, if nobody knows it, it's not the super simplest to learn. So it starts with an app, a silly app. I say silly, it's actually really nice. It finds out which cat you were based on a load of questions about whether you like playing in the sun or playing with balls of string. It's nice, it's a nice app. And so yeah, we have this code here. That's the place it is in GitHub. If it's not public, then sorry, I forgot to click the thing. Ask me, I guess. But yeah, this is an app. It's a Shiny app. There you go, it exists, but look, there's a Dockerfile there. And so this is what it looks like to build a Docker image, is that you define the steps that you would need to go to from a base Docker image that you wanted to start from, and then run the steps you would need to run in order to copy your application in and build it, and then run a command. And so this starts from this source Docker image, and we're going to go to our destination Docker image. Now, one thing about Docker images is that every Docker image comes from another Docker image, and it's kind of just Docker images all the way down. But just don't worry about that. This one has the stuff that we want. Don't try and find out where that one came from. But yeah, so we say, okay, there's this organization called Rocker that produce a image called Shiny, and it has Shiny in it, probably version 4.13. And that's what we're going to use to install our dependencies and to run our app in. And so you could also then think about, you could just, in your build steps, say, right, why don't we just build from the latest version of Shiny that there is? And in your dev branch, you could do that and just build the latest version of Shiny, and that's what you'll start running your tests against. And then, yeah, we copy a file. There's a file called required packages. It's got packages in it. We copy that into the build container, and then we do an install of the things that are in that package. But imagine if you did have a pack rat or an rend that you could have just done pack rat restore, and the whole thing would have installed itself. Wouldn't that have been nice if you'd packaged your app first? And so yeah, you copy your application code in, and then we define the command that when you run your container from your built image, we define what command is going to run in that container. And so in this case, it's going to run Shiny server because that's the Shiny server that's going to serve your Shiny app. So yeah, that's what a basic Dockerfile would look like that would take a real Shiny app and put it in a container, and I tested it and it ran. And so yeah, so you're taking your source code, you're writing a short, really pretty simple manifest. You are running Docker build to build those two things into a Docker image, a sort of state of a system, and then from that image, you can run a container. So it's crucial to note that once you've built your image, that doesn't mean that everything's fine and it definitely works. It means that you've defined something. When you actually try and run the container, there's a whole host of ways that it can go wrong. So let's talk about those. So the first one is that, let's say I forgot one of my dependencies. All I would see on the output is Shiny app started. I would not see any error that when a user actually tried to browse to the app, it all just went white and there was a little black cross, red cross, because the dependency was missing, because it logs to a file, because it's used to being on a VM, it's used to being on a system, so it logs to a log file. So we have to define this here, this log all your errors just straight out to standard error rather than log into a file. So that, because as I said, it's not a real machine, it doesn't behave like one. You've got to understand that you have to route traffic where you want it. You have to route errors where you want them. Also, by default, everything runs as root in Docker. Really, I don't know why. It's really bad. Because if you're root in a container, you're root outside the container too, and you can do really bad things as root. But it is, and so you can tell it to be the Shiny user, and then it's all safe because you're this user that doesn't exist outside. You can still run Shiny and everything, but it's more secure. Just don't trust me. Also, there's quite a neat thing in Docker, which is layer caching. So if you've got this, let's say this required packages was 1 million lines, well, not 1 million, a lot of lines long. When we did this R script install, that would take a really, really long time each time we did it. So what Docker does is says, okay, it caches each of the things that it does. So when you do that copy required packages.txt, if that file hasn't changed, it will go, okay, well, it's the same thing, so I'm not going to bother copying it, I'm just going to use the cached version. And similarly, then the next one will cache the fact that it's already installed the packages, doesn't need to do that again. Now, if you had copied your app code across first, and you were building every time you made a commit to your repo, then that app code would have invalidated the cache immediately, and then all of those packages would have to be installed every single time. So don't do that. Do the things that change the least often first. And if they take a really long time, try and do them first as well. So yeah, layer caching, something that you want to be aware of. And then finally, so there is a way that you can lint your R packages. You can lint your Docker files. There's a really nice tool, also cat-themed, as a lot of things seem to be. And it's handy, because it gives you an insight into best practices, and even checks your bash, if you're running bash scripts, to understand whether because you're not a sysadmin, you're not necessarily going to write really good bash. Even if you are, sometimes you write really bad bash. And it's going to check that stuff for you, give useful hints. However, use this at your own risk, because it will tell you to version every single package that you put there. It'll tell you to version every single apt install that you do, which you might not always want to do. But regardless, if you follow these kind of practices and use all these technologies together, you can take something that is, fairly simple architecture, and you can build it into an image and run containers on really scalable, really reliable, really portable architectures, and build out something for mission-critical applications that businesses might really rely on in Shiny, like this. You can go to that URL, and it's in Docker. Yeah, that's all I got. Thanks.